Okay, we're doing problem set 9, and you asked about number 4, right? So let's take a look at number 4. This is one of those valid, invalid type problems. It said, so let's write it down. It says, all well-educated people know algebra. So, oops, all well-educated people know algebra. And the second one says, we'll just call him Lao, L-A-O. Lao Zhu, is that how they pronounce that? T-Z-U? I don't know. Okay, we'll just call him Lao knows algebra. So here's their conclusion, and you have to tell whether it's a valid conclusion or invalid, all right? So therefore, remember the dots for therefore? Therefore, L-A-O, Lao is well educated. Now if you said it real fast, sounds pretty valid to me, doesn't it? So all well-educated people know algebra. Well, Lao knows algebra, so he must be well-educated. All right, sounds good to me, right? But let's take a look at the rules for the validity of this argument. First of all, look at the first statement right here. It's a lot easier if you change that to an if-then statement. That's what I would do. So it says, all well-educated people know algebra. How would I change that to an if-then statement? If what? If a person, start off with that, is what? Is well-educated, right? Is well-educated. Can't spell. There we go. Oops. Okay, then they know algebra, right? I'll just shorthand it. They know algebra. Follow me? Now it says Lao, L-A-O, knows algebra. Now look, in order to say that he's well educated, well, first of all, let's take a look at this. Let's change this to a different color. This statement right here, remember we call this the minor premise? We got a major premise and minor premise. Actually, let's see, how'd they start that? Yeah, the first statement was major and the second one was the minor premise. Watch. This has to relate to the if part of the statement itself. Let's see, does it? It says Lao knows algebra. If it was to relate to the first statement or the first section of the statement, the if part, you would say what? Lao is well educated. So what if they said this? If a person is well educated, then they know algebra. Well, this guy Lao is well educated. Then what can you conclude? Then you can conclude that what? He knows algebra. Is that what this is saying? It's not. This is saying Lao knows algebra. This relates to the then part. That's not how the validity of this statement works. Okay, it doesn't relate to the then part. It has to relate to the if part. Does this statement relate to the if part? No, it doesn't. So can you conclude that he's well educated? No. He might be great at algebra, but he doesn't even know how to read, or he doesn't know how to whatever, okay? He doesn't know anything about history or English or Chinese or whatever he is, okay? His language. You follow me? So just because he knows algebra doesn't mean he's well educated. But if it says if he's well educated, what does that mean basically? It means he knows all the subjects, right? So then, therefore what? He must know algebra. Does it make sense? So always look to this. Always change it to an if-then statement. Then take this statement right here, this minor premise, and relate it. Does it relate to the if part of the statement? Well, it doesn't. This says Lao knows algebra. It doesn't say that Lao is well educated, does it? All right. If it said he was well educated, then you can conclude that he knows algebra. But just because he knows algebra does not mean you can go backwards and conclude that he's well educated. Make sense? Let's look at the other one. Look at number 5. It's already if then. I'm not going to write this down. Let's just read it. It says, if the switch is on, then the light, oops. I'll tell you what, let's write it down. I'll pause it. All right, here's our statement. It says, if the switch is on, then the light is not on. All right? It's kind of weird, isn't it? Because, again, you think if the switch is on, the light would be on. But according to this, if the switch is on, I don't know, is there a situation where that could happen? If you reverse the circuits or something like that. Yeah, so if the switch is on, like in my basement, I've got an upstairs switch and a downstairs switch. You ever have that? And right, and so usually you flip it up, right, for the light to come on. But if you reverse it, if you go downstairs first and flip it up, then you're actually upstairs. You flip it down to turn it on. Make sense? Okay, so we'll call that on and off. So that's a situation, right, that could possibly work. So if the switch is on, then the light is not on. So I'm upstairs at the top of the basement, right? And I put the switch, the switch is on. I look downstairs, it's all dark. You follow me? Okay, so there we go. So if the switch is on, then the light is not on. That's our statement. We can believe it if we want, whatever. We just have to accept what they're saying is true. All right? Now this says, well, the light is on. Now remember what this has to relate to. This has to relate to what? The if part. Okay, if this matches up with the if part, then we can conclude this right here. You with me? Does this match up to that? No. This says the light is on. What's the if part? The switch is on. Do they relate to each other? No, they don't. So what do you think? Is this valid or invalid? I'd say it's invalid, and it is. It's an invalid conclusion. Well, let's think about this. It says if the switch is on, then the light is not on. Well, the light's on, right? So does that mean the switch is on? No. You can't conclude anything. You can't even conclude that the switch is not on, all right, from this. Because we're not saying, it's confusing. This is a weird example. They have better examples than this, but this is a weird example. But just remember this, that this minor premise has to relate to the if part of the major premise, all right? So this says if the switch is on. What if this thing right here said, okay, Bobby, turn the switch on, right? So it says if the switch is on, then the light is not on. Well, Bobby, turn the switch on. Then what can you conclude? Then the light's not on. Right, it's off. It's not on. Okay, then you can conclude that, couldn't you? All right, but in this case, that's not what it says. It says, well, the light is on. I look downstairs, the light is on. Can you conclude the switch is on? No, you can't. Little weird, but always do this. Always take this and relate it to this. So I drew the arrow. You don't have to draw the arrow, but mentally you should do that. See if this relates to this. If this is exactly the same as this, then you can make this conclusion right here. You get it? If it doesn't, if this relates to this, you cannot conclude the if part, right? That's why it says then. So if, then. This has to relate to the if part, then you can conclude this. All right, you can't take this, relate it to this, then conclude the if part. Make sense? All right, enough of that. All right, let's take a look at this. This is number 18 from problem set 9, and we want to solve for x, y, and z. So what would you do? I would do this. Actually, yeah, you could do the top and bottom, get rid of the z, or you could do the second and the third, get rid of the y. I don't think it makes much difference. Which one do you want to do? First and third, get rid of the z. Alright, so let's do that. Let's combine the first one and the third one, and we'll get rid of the z right there. So let's do this. So it's 2x plus 2y minus z. You might be able to do this in your head, but I would not suggest it. Alright, there's too much stuff floating around to try to do this in your head. So what I'm going to do is I'm going to combine the first and the third, and I'll get rid of the z's, and I'll just have an x and a y. All right. So let's go ahead and do that. Add up all our like terms. So what do we get? 4x. This is plus y. This added up to 0, and this is a 7. All right. I'm going to put that in a little box. You don't have to. I do that for safekeeping. I'll come back to that. It just reminds me to come back to it. Now I got rid of the z's here. Now that means I have to get rid of the z's in a couple other ones too. Which one would you combine? You could combine the first one and the second one, or the second one and the third one. I'd probably do the second and the third just because one's negative and one's positive. Do you see that? So now I'm going to combine these two together. So let's write that down. I'm going to write it right here. X plus y minus 3z equals negative 8. And let's do the bottom one. 2x minus y plus z equals 8. Now, we're not just going to add up these columns right now because that would get rid of our y, wouldn't it? If I just added them the way they were. I don't want to get rid of the y. I don't want an x and a z because then I'm stuck. I got to be left with an x and y. I have to get rid of the z's. So one step before we do that, This is just a z. This is a minus 3z. It'd be nice if that was a 3, wouldn't it? So that's right. So multiply this whole thing by 3 and multiply that whole thing by 3. You with me? All right, that way that will be a 3z. So now let's write it out again. So it's x plus y minus 3z equals negative 8. I haven't changed that equation yet. This is the one I'm going to change. Multiply everything by 3. That'll give me a 6x. That'll give you a minus 3y. And that'll give me a plus 3z. And that'll give me a 24. Alright? Add up the columns now. Now the z's will cancel out. Now they'll add up to 0. Do you see that? That's the whole reason that I did that. So let's see what our x's are. That's 1x plus 6x is 7x. That's going to be a minus 2y when I add those up. And what do I get here? Minus, what is that? 16? Yep, 16. Okay, and I'm going to put a box around that. Look, I've got one equation with x and y. I got another equation with x and y. Now I can combine those two together and solve for x and y. All right, and that's just normal stuff. You had one like that on the test, didn't you? So let's do that. It's 4x. It's a lot of writing, I agree, but if you break them down into little steps, it's not quite as bad. That's minus 2y equals negative 16. All right, you could do substitution if you wanted to. You could get y by itself, couldn't you? Y equals 7 minus 4x, and then substitute. Let's stick with the elimination. X, that's right. So multiply the top by 2 this time so you can get rid of the y. Multiply that by 2 as well. And let's rewrite this and see what we get. Again, it's a lot of writing, but it's not that hard. The math is pretty easy so far, isn't it? So that's 8x plus 2y equals 14. Then the bottom is 7x minus 2y equals negative 16. All right, now we're ready. The y's cancel out. I've got 15x equals what? Negative, oops, 2. Did I do this right? Okay, this comes out a little ugly, doesn't it? So divide by 15, so x is what? Negative 2 over 15. All right, let's solve for y.
How could you put that answer into any of them?
Yeah, into any of these, but I would pick the one with 2 of them, right? Because you can only, right? You only have one thing that you know. Probably solving for y right here would be the easiest way to do this. Okay, so I'm going to go 4x, so 4 times x, which is negative 2 over 15, plus y equals 7. So this is negative 8 over 15 plus y equals 7. Add an 8 over 15 to both sides. Alright? Now, if that's over 1, and that's 8 over 15. Find a common denominator, which is 15. I don't know, somebody do that for me. What's 15 times 7 real quick? Do it, quick, quick, quick. Who's got a calculator out? Come on, somebody move. Nobody's even budging. Alright, come on, do something. 15 times 7. Now you're going to make me do the work. Alright, that's 35, 21, 24, 245. Thanks for your help. Alright, so that's 245 plus what? 8? Well, this is kind of ugly, isn't it? Say, what's that? That's 253? That doesn't happen to go even, does it? I really doubt it. So that's what y is. Wow, that's ugly, isn't it? Tell you what, let me just take a peek, make sure I'm getting the right answers. I didn't make a mistake somewhere else. Okay, found my mistake. These answers are not right because I screwed up. Watch, one little negative sign. Look how dumb this was. Negative 8 plus 24 is not negative 16. What is it? It's positive 16. So that's going to be a positive 16. Let's see, where am I? Right here, right? Yeah. So everything's good. Let's see. That's 15. Yeah, this is 30. That's not that bad, right? I'm correcting him in red. So now, what's x? X is 2, right? There we go. That didn't kill me, did it? Now we just solve for y again. So I'll do all the rest of it in red here. So it's 4 times x. I'm using this equation right here. 4 times 2 plus y equals 7. That's an 8, right? 7 minus 8 is negative 1. So y is negative 1. Let's solve for z. Let's do this bottom one right here. So I've got, let's do it up here, 2x. Let's do it in our head. I'm running out of time. 2 times x, which is 4, minus y, which is minus a negative 1, which is plus 1, plus z equals 8. That's a 5. Z is 3. Bang, I'm done. There we go. Sorry about that. That was that simple little thing right there, just a negative sign, and that changes everything, doesn't it?